everyone. This is a review of the Friedman non-parametric two-way ANOVA test. Now for this test we have a blocking effect. This is sometimes called, sometimes could also be just a random effect. And we have a fixed effect. So I'm not going to go over the difference of a blocking or a random effect and a fixed effect here, but just note for Friedman's test, this isn't just any generic two-way ANOVA test. This is a specific setup with one blocking effect and one fixed effect. And if you need some more clarification on what a blocking or fixed effect is, please shoot me a message or leave a comment and I'll be happy to make a video about that. So Friedman's test, another way of thinking about this test is actually thinking about it of a difference between means to see if multiple means are different from each other when you have three or more dependent groups. So that's another way of thinking about it. For this test, we're actually going to use the notation Yij, where this observation, this is the observation, or the observed value for the ith treatment and jth block, where I can be in number between 1 up to k, and j can be a number from 1 to n. Now in a blocking setup, a way to visualize our data is we have these blocks. Block 1 all the way, let me actually write out block 2. Block 2 all the way to block K. And then we have treatment 1, treatment 2, all the way to treatment, sorry, this is treatment K, this is block N. And then so our observations would be Y sub 1 sub 1, Y sub 2, because this is treatment 2, but still block 1, all the way to Y sub K 1, because this is treatment K, block 1. Similarly, for this corner, we would have Kn, 1n, and we would have 1, 2, 2, 2, all the way down to YK2. So this is the a general way to observe the data, and what we assume in Friedman's test, or in this particular setup, or what we allow for, is that each of these blocks could have a different distribution. So that's kind of what's going on right now. So this could be the distribution of block 1, and maybe block 2 looks something like this. And we have a whole bunch of other blocks, and maybe block 3 or block K looks something like this, and any other variation of distributions. So we can assume we let the distributions or shapes be different. They don't have to be, but now they can be. Now the null and alternative hypothesis in this setup, we have H0, which is that the median of treatment 1, treatment 2, all the way to treatment K are all the same, and the alternative is at least one is different from another, or you could just say otherwise. Now, another thing I'm going to introduce here is the rank. So we're going to let rank Ij correspond to the rank of X, yij, comma, where this is the rank within group, or within block, rank within block, where 1 is smallest. And k is largest. Then our test statistic for the Friedman test. Well, let me actually introduce one more thing. Ri dot is equal to the sum from j equals 1 to n, Rij. So this is the sum of ranks by treatment. And then we have R bar I dot is equal to Ri dot over n, which is the average rank of treatments, of a treatment. Then our test statistic for the Friedman test ends up being k, which is equal to 12n over k, times the sum of k plus 1 times the sum from I equals 1 to k, r over bar sub I dot minus k plus 1 over 2 squared. This is distributed chi-squared with k minus 1 times, k minus 1 degrees of freedom. And so we reject h naught. If k is larger than some chi-squared k minus 1 at level alpha value. Okay, I'm going to stop here, and then I'm going to have a part 2 where I do an example.